Good morning, everyone. Hope you're all okay, and welcome to Friday's lesson on fractions. There's a short start on the video for you to have a look at, and what I want you to do is look at the fractions and match them to the fraction in their simplest form. Okay, so you have to divide, remember, both the denominator and numerator by the same number, and see which fractions on this side are their simplest form or equivalent fractions. Okay, so pause the video, have a go, and then we'll go through the answers. Okay, hopefully you managed to have a quick go at that. So 5/20ths in its simplest form is 1/4, because if you divide the numerator and denominator by 5, you would get 1 as your new numerator and 4 as your new denominator. 12/16, if you divide both of those numbers by 4, you'll get 3/4. And then this was a bit trickier because it's larger numbers. Actually, if you divide them by 20, you'll get 1/2. But you might have done it in a few more ways, so you might divide it by 2 or by 10, and that's fine because you probably still got the same answer, it just might have taken a bit longer, but that's completely fine. Okay, and well done if you got onto the extension as well. So we're going to carry on looking at fractions which are greater than 1, so carry on looking at improper fractions where the numerator is larger than the denominator, and mixed number fractions where we have the whole number and then the other fraction on the side of it. So just to recap then, on the video, so on your whiteboard if you're in school, if you're at home, just do it in your book. Can you write this as a mixed number using a part-whole model? And if you want to, as a challenge, can you write it as an improper fraction? So using our learning from yesterday, can you write it as a mixed number fraction and a improper fraction? If you're not sure, then we'll go through it together now. So we'll do the mixed number first with the part-whole model. So we need to work out how many wholes we have first. So we have 1, 2, 3 wholes, and then we have some left over. Now we need to work out how many makes up one whole first. So we have 1, 2, 3, 4, 5. So we know it's going to be out of 5. That's our denominator, and so each one is worth a fifth. Okay, now over here we have 3 parts or 3 segments, so therefore what is left? How many fifths are left? It would be 3. So we have 3 wholes and 3 fifths. So as a mixed number fraction, it would be 3 and 3/5. If you did an improper fraction, then it would be 3 times 5, which is 15, 16, 17, 18. So 18 fifths. Okay, hopefully you managed to get those. If you want to recap any of the previous learning from yesterday, then you can always go back and rewatch the videos. So today we're going to look at the same concept, but just from a different kind of angle. So using number lines and using kind of pictures to help us with it as well. So we have a box of lemons here. So we have 2 boxes. How many are in each box? So let's look at this question first. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 2 boxes of 10 lemons. If 12 lemons are taken, what fraction is taken? What would the denominator be? What would the numerator be? So if 12 lemons are taken, I will take them away. So we know that a whole box is going to be taken. Oh, that's not what I meant to be doing. Hang on, let me just pause the video while I work this out. Okay, sorry about that, I just had to sort it out. So I've managed to take all the lemons out of this box. So we know that 1 whole box has been taken. So therefore we would write 1. Oh, let me get my pen up. 1, because 1 whole box of lemons has been taken. You can see they're all gone. And then it's another 2. So what do you think our fraction would be then for this? Think of it as if these were shapes. Forget the lemons for the minute. That part's shaded and that's what we need to find the fraction for, these 2 shaded shapes. So we have 1 whole and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's out of 10, so that's going to be our denominator. Don't know why I went to write 20. It should be a 1. And how many are shaded? 1, 2. So therefore 1 and 2/10 lemons were taken as a mixed number fraction. If you did an improper fraction, it would have just been 12/10. Okay, so hopefully that made sense as I went through it and shaded which part we were looking at. We're going to have a look at another way of doing it now. So we could have used a fraction line to help show how many lemons were used. Because if we know that one box is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that that's one whole because that's one box. I'm going to put a 1 there. And we know that if we filled all these up with lemons and we took 12 away, we'd be left with 8 because I've done 20 take away 12. So then we just got to work out what this is, the non-shaded part is. So it would just be 1 and 2 tenths. Okay, so you could also use a number line to help you work out as well. So now I want you to have a go. So this time 16 lemons are used. So how many whole boxes are used? That's the first thing you've got to think of. And then what fraction of the other boxes used? So look at how many whole boxes are used and then think about the fraction that's left over. If you're not sure, then we'll go through it together now. So I'm going to use this number line. I need to work out where one whole is first because I know there's 10 in one box. So I'm going to count to 10 on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this point is our whole. So I'll write 1 down there. And we know that 16 lemons are used. So I'm going to colour in 16 this time. Let me get a block colour. What colour shall we go for? Let's go for blue. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's how many lemons were used, okay, as a fraction. So what I want you to do now is work out how many holes have been shaded or covered. It's 1 because you can see it goes over 1. If this was split into 2 separate boxes of 1, there's 1 hole taken up. And then how many else are taken up? What's the fraction that we're left with? 1, 2, 3, 4, 5, 6. And you know it's out of 10. So 1 and 6 tenths lemons were used out of the boxes. And if you wrote it as an improper fraction, then it would have just been 16. Oh, don't know what happened there. 16 tenths. It's been really laggy. I'm really sorry. There we go. Okay, so hopefully that helped a bit with your learning. So now we move on to our developed learning where we're looking at the number line. So look at the number line. What could the missing numbers be and how do you know? So we'll look at that question first. So we can see we've got 1, 2, 3 and 4 and they're all spread out on this number line. But we can see in between there's not, normally on the number line you have 10 spaces between each number because you know it normally goes up in tenths or decimals or that kind of thing. But these are only 4, so what are they going? I think of fractions. If they're split into 4s, 4 equal parts, what are they going up in? It would be quarters, okay? So each of these is a quarter because we can see when in each whole there are 4 equal parts, which would be a quarter. So we know that 1, 2, 3, 4 is 1 whole, and if we had 5, 6, 7, 8 holes, that's 2 holes. 8 quarters, sorry, is 2 holes. So therefore this part would be 2 and 1/4. Okay, this would be 2 and 2/4, 2 and 3/4. Can you think of 2 different ways of writing the number that the arrow is pointing to? So if these were all quarters and you counted up in them, you could write it as an improper fraction as well, because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters, because we know that these are broken up into quarters. Okay, so 2 and 1/4 would be our improper fraction. No, sorry, mixed number fraction. And 9/4 would be our improper fraction. Okay. Hopefully that makes sense. I get that it is quite confusing. It's a tricky concept to get your head around, but the way I look at it is I just look at what one whole is. So I look at the first part, see what it's divided up into, and that's how you can work out your first fraction. And you just go from there, really. Once you've worked out the fraction, you've done the easy part. You just need to then add up the numerator or add up how many holes there are. So hopefully that makes enough sense. It is your turn to have a go now. So group 1, you have some questions which link to our learning from yesterday just to consolidate that learning. So if you're feel a bit iffy with this, then start on group 1, and then in the last part of group 1 there is a question based on the number lines. So if you want to do group 1, you might want to pause the video now so you can have a look at the questions. This is the second part for group 1, so it's still group 1. There's another question based on yesterday's learning and a question based on today's learning. And then group 2, this is your first question. And this is your third one. Second one, don't know why I said third. And then this is your third question. And the challenge, if you want to have a challenge. Make sure you come back to the video afterwards because we'll be going through the answers at the end. Okay, welcome back. Hopefully you managed to have a go at some of those questions. We're going to go through the answers now so you can self-mark it. So circle the part-whole model for the number of circles. So we can see we've got 1, 2, 3, 4 holes, which is what's written there, and we've got 3, and you've got to work out what the denominator would be. So the denominator is what the shapes are split into, and they're split into quarters, therefore it's 3/4. And as a, that's wrong, as a mixed number fraction it would be 4 3/4. So there are 4 holes and 3/4, or 4 3/4 circles. The bottom one, complete the part-whole model for the number of hexagons. So we have let's count the holes first. 1, 2, 3 holes. I'll write that there. There are 3 holes. And there's 1 left over of something. So we need to work out what the denominator would be for that. So the hexagon is split into 1, 2, 3, 4, 5, 6. Therefore, they're split into 6. Okay, so therefore, if we put those together, we've got 3 1/6. So for the bottom part, there are 3 holes and 1/6, or 3 1/6 hexagons. Okay, hopefully that will make sense. Okay, for the next part, it says write a number of shaded rectangles as a mixed number. So we have 1 hole, 2 holes, so 2 holes, and this part we've got 1, 2, 3, 4, 5 shaded out of a possible 1, 2, 3, 4, 5, 6, 7, 8. So the rectangles are split into groups of 8. So therefore there are 2 holes and 5 8s. The next part, each box contains 8 apples, 13 children take an apple. How many whole boxes are used? Now you can use a number line at the bottom to help. So if we know that 13 children take an apple, we are going to count up 13 on our number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, because the number line's here to help you. So if we have 1 whole, it's always split into 8s because each one is 1 apple. That's a whole because that's a whole box. And then you carry on. So therefore 1 whole box is used because you can see we pass 1 whole. And we then have 1, 2, 3, 4, 5 8s left over. And you could have also used the pictures to help you as well. Okay. For group 2 then, what fraction is shown on the number line? So you just have to count up in quarters and keep going really. So 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters. And this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm sorry if there's a commotion in the background. I have someone fitting a new tap in at the moment, so it's a bit noisy. So this is group 2. Complete these number sentences. So we have 2 wholes and 2 fifths, which would just be let's use a number line actually to help, then I can show it to you. So this would be 0 fifths because it's on 0. Then we have 1, 2, 3, 4, 5. Hopefully that one didn't throw you as 1 because I was about to put 1, you can see, but it's actually 0. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 2 wholes and 2 fifths. So therefore we know we've got to do 2 wholes, which is here, and then add 2 more fifths onto it. So 1, 2. So therefore we know it's 12 fifths as an improper fraction. This one, 9/6. So we need to find 9/6 on here. We need to work out how many holes there are first. So this is where the hole is, because you know 6 sixes makes 1 hole. If you thought of a shape that was split into 6 groups and they were all shaded, that's 1 hole. So there's 1 hole and 1, 2, 3 more 6s, which is 1 and 3/6. The second part of group 2's questions, write the number marked in 2 different ways. So these are split into 1, 2 thirds. So each part is a third. And that would be 2 thirds, 3 thirds, and so on. So 4, 5, 6, 7, 8, 9, 10. So it's 10 thirds. And we know it goes past 3 holes, but not quite 4 holes. So it's 3 holes and 1 extra third, which is 3 holes and 1 third. And then your challenge, Lexi draws this number line and he says the arrow is pointing at 1 and 1/2. Do you agree? Explain your reasoning. So we can see that this is our whole, because you've got to find it when the numerator and denominator are the same. That is the equivalent to a half. So 8/8, think of a shape that was split into 8 sections and they're all shaded. That would be a whole. So that's going to be 1, and then we'll see how many extra we have. 1, 2, 3, 4. So we have 1 and 4/8. Now that isn't the same as that. However, it is still equivalent. How do you think we can make that equivalent? Because the whole will stay the same, but we could divide 4/8 by 2, which would be 2 quarters. And so we could divide that by 2 again to get 1/2. Okay, so we're just simpling down the fraction, and it's still the same, it's still equivalent. It's just a simplified mixed number fraction. Okay, so therefore he is right. He's just simplified the fraction. Okay, hopefully that all makes sense. Any problems or any questions, please let me know. Thank you for watching. Oh, and have a good weekend.